you have any questions about? No? Fire up Slack. Post this. I know at least one person will. Computer, you can do it. No question. Objects and what we, all right. So today we're going to do a lot more review of objects because this is such a foundational concept. We're going to be just creating the same object several times during class, and then after that we will go over a little bit more information on the object prototype, and then I might, depending on the time, spend some time talking about just some other sort of random topics around web development and stuff like that to try and give you guys a little bit of a basis with some of that information. All right, so let's start off. Can anyone tell me what an object is? What is an object? Something with properties. There we go. It's a great description. And properties can be modified. They can be colors. Yeah. Yeah. Yep. Those are all great. They can be any type, right? So, and I know I've done this many times. You guys are getting better at it. So, what are some of the types that we've learned in JavaScript? No. Array. Undefined. Functions. Numbers. Yep. And objects. Right? Properties on an object can be any type in JavaScript. They can be any of those. They can be null and undefined and functions and other objects. And we did a fair bit of that sort of, at least conceptually, last class, talking about object composition and building an object out of different objects. And then we also touched a little bit on, we'll talk a little bit more about today. So for review, we also went over several different ways to create objects in the last class. I don't know if anybody looking over those in any more detail, but we're going to go ahead and create objects using each one of those approaches again, or most of them at least, just to help reinforce that. So we'll be creating the same object using each one of these approaches. That way we're not trying to think about different properties and changing that up each time. And well, as it says up there, I'm a nerd. It's like, okay, that's probably not a surprise. But I have typically nerdy hobbies like reading, discussing the merits of Star Wars versus Star Trek, and playing RPG games. So I think let's go ahead and appeal to my own nerdy hobbies today, and we'll create an object that represents a character in an RPG game. That seems like something that has a lot of potential. You know, maybe we'll expand it beyond what I have here initially, but we've got sort of a starting point that we're going to start off with, and that's this set of properties that I've got up here. We want to create properties for the name, experience points they have, their level, class, strength, and intelligence. So these are the different properties that we definitely want on any object that we create, right? If we get creative beyond that, great, that's awesome. But we'll go ahead and start with that. Exactly, right? And I'll almost guarantee you somewhere in the WoW code base, they've got objects that represent their characters with this sort of core information in there. So let's get started. We've done object literal for a few classes now. Object literal syntax for these types of objects. So if we have Let's go back here and go to the same properties that we had said we wanted to use. Got them up on the screen. How would we create an object using object literal syntax with these properties? And we can give them whatever values we want to give them as we create it. Does anyone want to get us started? Var character. That's great. And how do we curly brackets? Awesome. So let's do it. I'm going to set them in line on it as opposed to, no, you know what? I'll do it this way. It works just fine. So var character. All right, so we've got a character. So now how can we add properties to them? Dot name equals, what should the name be? Laura. Spell it right? Yeah. All right. Let's set some other properties. What are the other ones that we need on here? Experience points. All right. How much experience does Laura have? 50. All right. And we want to help set another one.
Level.
So how do we do it? Character.
0.
Character dot level equals 0. Oh, they're not even level 1. Ouch. Harsh. Yeah. All right. Character dot class. Dwarf. Dwarf. That's a race. What's a class? Like fighter.
Mage.
A mage. All right. Let's change it. Let's make it a mage. There we go. We went ahead and set it, and then we changed it because we can do that. Let's give a strength value. 8. All right.
Drawing on our campaign
Character. All right. Intelligence. We're gonna go with a good 16 here. A good big beefy intelligence number, right? So we've created now we have an object, right? If we did type of character, confirm it's an object, and it's got all these different properties on it. All right, you guys did great. That's, just review of creating object literals in JavaScript. And we could have done the exact same thing with setting it within the brackets. The syntax is slightly different if you do that, so I'll do that just to show you again. But if you didn't, like you left your bracket open, then you can do name colon and give it a name. And then you do a comma between each property. XP, level, class, strength, and intelligence. And then you close it with a curly bracket. And sure enough, we've got an object with the same properties. You know what? That sends me down a quick rabbit hole. Just practice this with you guys. So I think it's a good thing to think of. Now we've got this object with the same properties that we just created. I'm going to have another object refer to it. So let's say we'll call it temp equals character. And then I'm going to create an object with these same properties again. So name, Laura, XP 50, level 0, class mage, strength 8, and intelligence 16. All right. Let me just verify that. Awesome. Let me verify the temp. Sure enough, it looks like they have the same values. So what do you think is the result of evaluating this expression? Temp equals character. I'll even make it triple equals so that it's clear that it won't do any weird type coercion. What? All right. Who thinks it's going to be true? Huh? Who thinks it's going to be false? Who has no idea and they're afraid to answer? Okay. True? Okay, let's hear the reason for true. Why do you think it's going to be true? Right. It has the same values, right? All right. Somebody who said false. Why do you think false? Like, oh no, I'm on the spot. I'm putting my head down. I'm not really here. Yeah, you are. Why do you think it would be false? All right. It's false. And I think this wasn't what I was intending to do right now, but I think it's a great example. I'm going to go over to the whiteboard real fast and sketch this out. But remember, a long time ago, we talked about the difference between value objects and reference objects, or value types and reference types. And we said numbers are value types, and other things, objects, for example, are references. So basically what we've done here is we created an object, and I'm not going to write it all out. And this has name, it says it's this, and XP says here. And what we have is something out here that originally refers to this. Originally, character pointed to this object in memory. And then we also said, okay, let's set another value. Let's call it temp. And it's going to point to this same object. So it's pointing to the same place in memory, the same object. And then what we did was we created a new object that just happened to have the same properties, or the same values for all the properties. So it had the same properties and the same values for them. And we took this character variable and changed it so it was no longer pointing to the original object, it's pointing to this other object in memory. And then when it goes to check and compare against these, since it's not checking the value, it's checking if they refer to the same thing. It says, yep, these are not the same thing at all. 1 point's here, 1 point's here. That's different, so it's false. And if you want another way to prove that or to see it, now that we have temp pointing to one object and character pointing to a different one, if we change temp and temp dot xp equals 0, and we look at our temp object on the screen, we can see that it has 0 experience. And if we look at our character, we can see that it still has 50. And that's because they're actually different objects of memory. They just look the same. We just gave them the same set of properties. And that's something that you run into quite frequently, where you have objects that look the same but have different properties. And there are ways to do comparisons against those. Probably a little bit, I don't know, maybe I'll give it as an assignment. I might make an extra assignment to compare 2 objects property by property to see if they're the same after class. That would be a pretty stretch assignment for where you guys are at, but I think it would be a really good one for people to try out to get a feel for it. All right, so we've done object literal syntax, but I mean, frequently when let's say we're making this game, we're trying to build something to help us do this. Well, you're gonna wanna create a lot of objects that have the same properties. Let's say I want a whole party for an RPG, I don't want just one. It's a little tedious to write out each one completely in this fashion. Plus it's error prone. If I accidentally typed one of the properties wrong, then we may have an issue. So let's use an object factory or a factory function to create as many objects as we want with the same properties. Does anybody remember how to create a factory function to create objects here?
Will be function.
Let's
Character generate.
call it character factory. And let's say it probably needs some properties. There's at least some stuff that we need to pass in because it's going to be unique to each character.
Name, level.
Name. Well, let's just say for each character we're going to start them at the same level and experience and some of that stuff. But name and class.
Race.
Yeah, we could give them a different strength, intelligence, if we want to. Right? Okay, so now we have a function that we're writing out here. And what we want to do is take the data that we got in and create an object and return that object so that we can create objects of this same, with these same properties quickly and easily. So what do you think the next step would be?
They essentially just need to assign the task to generate the name, class, strength, intelligence. So it would be like name dot character factory equals and then empty bracket.
Would it be like this
Yeah, see, I think it's I can be a little misleading here because it's a little hard to tell the difference. That would be what's known as a function constructor, but yes, that's one way to do that. We're going to do this with a factory, so what we'll do is we'll come back to that approach in just a second. So we're going to create this pretty much just like we did before. The only difference is we're wrapping it inside of a factory for this function. So how did we create our character before? Our character equals, all right, and then and what's the name going to be equal to? What? No, it's going to be whatever they pass in for the name when they call this function, right?
Yeah.
So the name property is going to be equal to name, right? So then we also have experience, and that's going to be the same. Everyone starts off with no experience. Because this isn't quite as mean, everyone starts off at level 1. And all right, what about the class? Yep. And now let's say we don't require people to pass in. This is something interesting in JavaScript, not something that you guys need, matters too much, but I'm going to do this for fun to introduce you to new concepts as well. You don't always have to pass in a value for every property. Not every property in a function has to actually have an argument when you call it. And if it doesn't have one, then it's null, which happens to be falsy. And using a little shorthand that's very common in programming, I'm going to do something here where if so this little shorthand is a little bit of a trick. It's a little bit of a lazy way to do something, and it doesn't really matter. I'm just trying to introduce you to some new concepts. We only have a few classes left, so you guys might be comfortable as you read more code outside of this class that other people have written. So this is saying character.strength equals strength or 10. That's a little weird. It works because of JavaScript's truthy or falsy. So if somebody passed in a strength value, then if that strength, if it's actually a value and it's not 0, it's truthy. So we'll set it to whatever that is, because whenever you do an OR expression, you shorthand, you don't calculate anything more than what you have to do. So if this is 1, then this will say 1. That's truthy, and it's like, okay, good, return 1, because it's an OR. But if it's null because they didn't pass a value in, then that's falsy, and we'll look at the second part of the OR expression. And it will say, okay, 10, well that's truthy, so that's my value. And that's sort of a shorthand lazy man's way to do a default value there. So we'll look at that. You'll get to see what that looks like when we call something. And we can do the same thing with intelligence. All right, and then what's the last thing we need to do? If this is a factory function, we've created a character in it, but we need to be able to work with it outside of this function.
Return character factory.
You just need to return the character that you just created. And of course, I screwed something up somewhere. So JavaScript is angry with me. And I will need to rewrite this because I don't know what I messed up. Can anybody see what I messed up? I don't know, so I'm going to try and write it over here in a file where I'll get better syntax and other stuff. So I know what I screwed up. It's very subtle. Class is a word that you really shouldn't be using. I don't know if that's actually it, but it's something that you really shouldn't use because it's a reserved word in JavaScript. Oh yeah, you can't use it anymore. It's a reserved word. So we'll call it like class type so that we're not colliding with one of those reserved words.
What about job?
Job, role, we'll call it role. Character.name equals name. Character.xp equals 0. Character.level equals 1. But you can have a property of class, and that's because it's not going to be reserved a keyword. But we're just going to call it role from now on so that we don't have any issues. Strength or 10. And we can return our character. I'm just going to cut and paste this over into here because I think it'll work now. We'll see. All right, so let's create a new character. What should we name the variable for it? We're gonna call the variable the leader. I don't know. And we have a character factory. So now let's give him. Let's pass in the parameters. So the leader, what's his name? Her name. What? Kita?
Yeah.
All right. What role does Kita have?
It's night.
Night. That's awesome. All right. How strong?
I'll say it's like 17.
17. Really strong. All right. And let's not set an intelligence. Oops. I didn't call this right, did I? I need a Y on factory. All right. So let's look at our leader. So sure enough, we've got a object, the name, the experience and level that we set by default, the role, the strength, and the default intelligence that we fell back to because we didn't pass something in. So when it ran through the code, it saw null and set that. So let's create another person. Call this one the fighter. So our character factory, what name does the fighter have?
Balboa.
What?
Balboa.
Balboa. I'm going with Balboa because it makes me think of Rocky.
Yeah.
It's a fighter, Rocky Balboa. I like this. Class of boxer. That's right. Whatever RPG this is, it's like a little bit like a Street Fighter, you know, RPG mix. Like, you know, it's like the boxer guy. And what's his strength?
Ten.
10. All right. Intelligence? 5. No, he's been punched a lot.
It's like he's in my head.
This fighter's been punched a lot. All right. So there we go. What we can see is we have, we look at our fighter, type of object, and our type of leader is object as well. So we've got another way to create objects, except this time, every time we create one, it takes a lot less code for us, right? We have to type a lot less because there's a lot of stuff that we can just reuse. Even if we set every one of those properties, it would still be a lot shorter to set those using this sort of factory that generates and returns objects. And each one of them, very much like we have on the board here, is a new object that it's returning each time. Does that make sense? I mean, it's really just doing the object literal syntax, except we're creating it in a function and returning it from there. And by simply adding that function wrapper around it, we get a whole bunch of code reuse very easily. So now, let's revisit this. All right. Last time we introduced the concept of a constructor function. And a constructor function is a function that happens to be called with the new operator. And when it does get called that way, it will return an object. So it returns an object. And it'll behave similar to an object factory in that we can create multiple objects of the same type easily, but they come with additional benefits that we'll see in just a little while. So now, Laura, let's convert this over, because you were already heading in that direction before, to use a constructor function. So if this is a constructor function instead of a like factory function, how would we set the name for this dot name equals name, right? And the syntax is a little weird, because you're like, okay, this dot, we've introduced this a couple times now. Remember, it refers to the object that you're working with. And when you're doing a constructor function, inside of this constructor, this refers to the object being created. So we can also set XP the same way, and level, and role. And we can do strength, intelligence, doing the exact same thing. Now, one of the differences here with a constructor function and a factory function is this doesn't need to return an object itself because we call it with this new keyword, and by calling it with that new keyword, so I'm gonna change the name of this too to be character, because it's sort of a common syntax to name your constructor functions with a capital letter. It's just it's a common pattern so that when you look at it, you have the idea that, oh, this is probably a constructor function. It starts with a capital letter. So we've got our character function. And so now let's go ahead and create a mage using this. Does anybody remember the syntax for this? How we call this constructor function? People familiar with other object-oriented languages can probably take a guess. Nobody remembers? Use the new keyword, and then we call it like we would any other function. So what should be the name of our mage? We're gonna go back to Laura. This is Laura again. And the role is mage. And the strength, just average, but this is a mage, so we have to have pretty strong intelligence, right? Look, I never actually copied this code and ran it down here, so it didn't exist. All right, let's try this again. We're going to create our mage now. All right. And now we've got a mage object. And this looks very similar to our leader or our fighter. Now, if you look very closely, though, you can notice one thing that's different between the mage and the leader. Hint, it's not actually inside the brackets.
One says character, the other one doesn't.
One says character, the other one doesn't. Yeah. This is some of the information that you start getting when you use constructor functions. Because if we look at our leader.constructor, it's going to tell us it's a function object. This may actually not work out the way I want it to. We'll see how this goes. Mage.constructor. This tells us the function was basically the object function, so the base level object, the most basic object you can create. Whereas our mage constructor, which is a property on our mage that it got just through being created, not one that we added, but one that came from JavaScript itself, it's this character function that we just used to create it. So something that's really cool about that is now there is something we can compare to see if two things are of the same type at least, or were created with the same constructor, right? So now if we create another character, I don't know what type of character we need in the party now. A rogue, all right. And the name for our rogue shall be Zalnork. I don't know. Zalnork is a rogue. Average intelligence, a little above for average strength. Yeah, we'll go above average strength and above average intelligence, but nothing amazing. And so we've got our rogue, and now we can check rogue.constructor equals mage.constructor, and that's true. And so now we know that those were both created using the same constructor, which is really cool. So we can sort of tell, oh, these are probably the same type of object. We're starting to learn how to distinguish different types of objects. So that's one of the big benefits you get out of constructor functions immediately from using it. You also don't have to write all that factory function code. And so you get to use that sort of this syntax. Now there are pros to factory functions too, and so each one has pros and cons associated with them. All right, so we've done, these are really the main three. I've got one other, and I don't know if we need to go through it, but I'll give you guys a shot real fast, because we're gonna play with it maybe a little bit more later in class, but let's talk about object.create. So this was one other way to create an object. And does anybody remember how you used object.create? From last class?
You make a variable.
Yeah, it's a lot like an object literal. Yeah, yep. Yeah, it's a lot like what we did before. So we're going to have, I don't know what we're going to have. We're going to have a, we're going to have a dragon. Why not? But object.create, and it's just a function or a method, just like anything else, and you can call it. That tells you have to give it a prototype of some kind. So if we want to be really lazy, we can say, just give it this empty object as your prototype. And then we could add whatever we wanted to onto it. And this one, he's got like tons of experience. He's a dragon. I don't know. It's like level 99. Strength is massive. Okay. And he's really smart. And so sure enough, we've got the dragon's got the same properties as what we had before, right? And so this doesn't look very fancy at first. When we first introduce it, it looks very similar to object literal syntax. We don't get much value from it, but you'll get to see some of the value that you can get out of using object.create in just a little while when we start looking at prototypes in a little more detail and talking about prototypes. So let's go back. Let's talk about object relationships again. One of the things we talked about last class was the different ways that you can have relationships between objects. Do people remember the two different types of relationships that we discussed in class last time? You're looking at the lesson, aren't you?
No, I actually wrote it down.
Ah, good job. We have inheritance. Yeah. Does anyone remember the other way? The other like object relationship that we talked about? That was composition. We talked about composition and inheritance. And we gave sort of a two-word bit for each one of those. So composition, does anybody remember, was what type of relationship? It's like a car, blank an engine. What's the relationship between a car and an engine? It's a property of a car. Yeah. What? Has a. There we go. I like that. Yeah. A car has an engine, right? A car has a door, hopefully more than one. Car has a drivetrain. The car has a steering wheel, right? Does anybody remember the term we used to describe inheritance type relationship?
It's a default set of things that an object has.
I already heard it. Is a. Yep, is a. So a car is a vehicle. And let's think about some other ones, right? Like a character is a creature in this game or something that we're making, or let me see, what might be another good example? The Crest building is a building, right? It has the properties of a building. So that's the difference between a composition type relationship and a inheritance relationship. It's a little different. Again, like I say, inheritance might be slightly confusing because the terminology is slightly different than what you're used to. It's not in the sense that I inherited my eye color from my parents. It's more just describing a more generic type of object that you are, right? So, what's that?
Can you go real quick? No, in the terminal.
Oh,
Okay, right there.
so the has a relationship is pretty simple for us to build out. It's not very complex in terms of creating that association, at least initially. On its surface, it looks really simple. So if we're creating the has-a type relationship in code, and let's say we're still working on our RPG here. So let's make some sort of awesome, I don't know, armor. So we're going to create an armor object, var armor. And let's give this armor some properties. So what are some properties of the armor? It adds some defense to you. Spell defense right? I think so. So let's say it adds, I don't know, 5 to your defense or something. And it has a style. What style of armor would this be? Plate. All right, plate mail.
Leather. It's fine.
Leather. Ugh.
Yeah, fair enough.
Well, you guys both lose out because I happen to be wearing chainmail on my wrists. So we're going with chainmail. What might be another property of it? Durability. Let's give it some sort of durability. Let's say it starts at 100. All right, so now we have this armor object, right? Pretty simple. Now we have our fighter from before. So let's give him some armor. How can we give some armor to our fighter?
Fighter has chainmail. No.
Yeah, I mean, it has a relationship, but it's the way, how do we add anything to an object? It's just another property, right? So let's say his armor is this armor that we have, right? That we created. And now if we look at our fighter, you can see, all right, we've got all of our basic properties that are strings and numbers, and then he has another object, which is this armor, right? And that's pretty much the basics and the crux of sort of that has a relationship. It's just another property. But it's useful to talk about because it is used in contrast both to the is a relationship, and it's actually the preferred way when possible to construct these sorts of relationships because it's much more flexible. If anybody really cares about the details of why it's a preferred approach or anything like that. I can spend some time at the end of class or after class going over it. But it's much more something that has been learned through experience as we've developed object-oriented programming, that this is the better relationship to have most of the time than the is-a type relationship. But we also have this is-a style relationship. And in JavaScript, the way that you deal with this is-a relationship is through the prototype. And so we talked about this a little bit last class. We started discussing it and showing a little bit of how this works, but all objects in JavaScript have a prototype. Every object does. The prototype is, I say also, is either an object or null for like the lowest like root level object. And a prototype is, as it says, just another object, and so the object inherits properties and methods from its prototype. And this inheritance allows for powerful reuse of your code. So when JavaScript looks for a property of an object, it first looks on the object itself, and if it doesn't find it, then it looks on the prototype of the object. And it will just keep going down this prototype chain perpetually. So let's play around with this just a little bit just to see what we have. So we have let's look at our mage, because the mage was created from this character constructor, right? Mage.proto. And this isn't something, I'm not explaining this because you don't necessarily need to know how to get access to the prototypes this way. I'm just sort of showing off that you can see it. So this is the mage prototype is sort of this character object. That's interesting. That looks a lot like what we just saw from the mage.constructor too, except a little different. There it's the function, and here it's like this character object. All right, but I said, remember, every object has a prototype. And that prototype is either an object or null. So we can just keep moving down this chain because you can chain these dots together perpetually. So what's the prototype of the character object? Well, it's this empty object. And what's the prototype of that? And we've hit null. And so, of course, we know null isn't an object, so it's not going to have a prototype. So that tells you just how far, like, we're sort of 3 steps removed from null. There's 3 objects in this prototype chain. And if we were to draw that out on the board, and we don't know what fits into each one of these right now. But if we were to draw this out, you have your character that we've created, our mage, and our mage has certain properties, like the name, and the experience, and the level. And one of the properties it has is the prototype. And that prototype refers to a very weird arrow that points to another object. And this is the character object, which has some properties which we really don't know about. We haven't looked at any of them. And he also has a prototype. And that points to this gun. That points to this base sort of object that we saw, which also had a prototype. And its prototype was just null. And so whenever JavaScript is looking for a property on an object, it's first going to check your object itself, in this case, object for that property. And then if it doesn't find it, it's going to walk down the prototype chain And you can see that looks like a chain, right? They're all just chained together, looking for that property until it can't find it. And if it doesn't find it anywhere, it'll tell you undefined. So if we look for, what don't we have? We don't have armor on our mage, right? So that's undefined. Because it's not actually on our mage. So let's start playing around with this a little more. Let's look at some of the power we get out of this prototype. So revisiting our character object from before, we're going to go ahead and set some methods on the prototype of the object so that all instances of the same object will inherit those properties. So the easiest way to do this, probably the most common, is setting them using this constructor function approach again. So revisiting our constructor function, any properties set inside the constructor function like we had before are going to be properties of the object itself. You can't set the prototype properties inside of your constructor function. So we already did all of this. This.intelligence, this.strength, this.level XP, class name, etc. So if you want to set prototype properties, you can set them outside of it like this. So let's go ahead and I'm going to just copy this. And I'm going to set this character.prototype.greetings. And of course, I have a typo or something wrong somewhere in this. Oh, yeah, you can't write it out exactly this way. The way you need to write it is this equals function. There we go. I will need to fix that in my notes before I upload them. All right. So now I'm going to go back up here and let's look at this prototype on our mage. That's right, our mage, we set a new property on the character prototype, this constructor function, which is this greetings property. And since we set it on this constructor function, anything that was created from it gets this object, which is an actual object, as its prototype. So now, here, there's a greetings function. And this is a really complicated piece of code, so we're going to spend a little bit of time walking through this and how exactly this works. But if we look at our mage object itself, you can see we don't have this greetings method. It's not on there. But if we call mage.greetings, oh, I need to fix my function because I wrote it wrong, didn't I? I was still with class. Fix that. Console.log. Role, right? That's what we called it. Let's try that again real fast. Mage.greetings. And so this is a really complicated bit of code here, in a sense, right? There's a lot of stuff going on. I'm going to fix it real fast so that I don't have this written wrong. I'll fix this one too. Go through all of this and fix it later, but So let's try and walk through this because it takes a lot to sort of figure out what's going on here, right? We've added this greetings method to our character object, or our prototype of our character. A lot better over there on the whiteboard, doesn't it? Unless that's just me. Maybe I just can't see over there. Here, and we call that method, and that method has, my name is this.name. I have a powerful this.role. Now when we call it on our mage, this is our object that we're referring to, this, right? And that's sort of the key part here. This is where JavaScript can behave a little differently than some other languages. But the mage is what we called the greeting on. And it looks and says, okay, I don't have this greetings method. So let's check and see if my prototype does. Sure enough, it does. So we're going to run that greetings method and execute it. And while we're executing it, it's going to check my name is this.name. But this doesn't refer to just the character that we've already gone down to. This refers to whatever object we were calling it in the context of. So it goes back and says, oh, where's the name? Oh, let's check on this object. Oh, there's my name. And then it keeps running. I'm powerful role, and it's going to check here for that information first before it checks farther down, because this is the context that we're running in, is the mage. That's what our this is, and that's what this is because we called mage.greetings. That makes sense. It should be a little bit confusing, but makes a little bit of sense too. Yeah?
So all the character
What's that?
so the character that prototype is called that class.
What we actually did with that was, and this is the way these constructor functions work, right? Is when you add something to the prototype of a constructor, this is an actual object. The constructor function itself is an object, right? Remember, functions are objects. They're just sort of special case ones. And so we added our greetings method to this. But since anything created off of that constructor function is going to have the constructor object as its prototype, then it's able to call down to this greetings method as well and have access to that. And we can add it to any object that's been created off of that. It's a little bit of magic, a little bit tricky. In most object-oriented languages, you have to have sort of set all of your methods ahead of time that you know you're ever going to want to have on objects that you create from something. You can't add methods later by adding them in this sort of way. And you especially can't add them to everything, because what else? I can't remember what other our constructor function. Does anybody else remember? I don't think it was the boxer or fighter. Was it our rogue? Okay, it was our rogue. So we can do rogue.greetings. And because he was created with that constructor, that same constructor function, he also has a greeting. But our other ones that weren't, they don't have that method in their prototype chain.
It has this thing and this role. You're able to call it.
Well, they don't have it because if we look at our fighter. Oh yes, yeah, because they have a name and a role, right? If we and you wouldn't do this, right? Let's do our rogue again. Let's spell it correctly. So let's I'm going to do some code here that you guys don't necessarily need to know, but rogue.prototype.name equals Filbert. Oh yeah, I can't set the property name of undefined. It's not going to let me do it that way. I don't know if it'll let me do this either because you really shouldn't do this, so it might protect me from this. So if we look at our row, we can see what our name is. Now, if we delete our name off of our row, which, like I said, not something you guys need to know how to do, we can see we don't have a name anymore. But if we did rogue.greetings, he still prints out a name, and that's because we added something to our prototype object. So instead of adding it to, and we sort of deleted the name here, and then when greetings is called, it's going to check for a name here. It doesn't see one, so it moves on down to the prototype, where there's now a name for it to use. It keeps moving down that prototype chain. Now, if instead we add our name back to our rogue, and we run that same thing, now we don't get Filbert anymore, and that's because when it's walking down that object chain, it sees a name here, and it uses it. It doesn't have to go to the prototype to keep looking for the name. It found it in the very first step in the chain, right? Now with our mage, we can do the same thing. If we delete the name and we do mage.greetings, we can see that it's still got Filbert because it walked down the prototype chain looking for some property with that, and it found it in this second level of it.
It's kind of like what they do for default names. Do you quickly think?
I mean, something like that, yeah. There's a lot of ways to set defaults. Like you saw me setting default strength and intelligence before. And this is sort of a little bit unique to JavaScript. Not exactly, but the specific ways of how this works are I would say JavaScript and maybe a few other languages, but it's not the most common object-oriented model. Most object-oriented languages, instead of using this prototype concept, they have an idea of you can imagine a blueprint, right? You have a blueprint for a house, and then you can, okay, I want to make a copy of that house. Well, here's the blueprint. Go build a copy using that blueprint, right? That's the way most object-oriented languages work. Instead is like, oh, I want to have a house that looks like that house. And they go, oh, well, here's a copy of the whole house. Why don't you start with that? Essentially, instead of having a blueprint, they're like, oh, you want to have a house that's like that? Here you go. Have the house. Start with it. And that's sort of the difference between JavaScript and most object-oriented languages is instead of using classes and building off of them, these blueprints, and builds off of objects. Everything's just sort of existing objects. So we can add other methods. Let's add another method, a much more complex method this time around, to our character class or our character prototype here. This method allows us to gain experience. So let's have our mage gain experience. Right? We don't see anything, but we could look at the mage now and see that mage has gone up because we changed the value of that property on our object. And then if we want to gain even more, right? Let's gain 1,000 experience. And we can see that we printed out the message that we had built into here. So we checked if our experience was more than 1,000. Then we leveled up. We remove 1,000 experience because we're sort of being lazy here. Instead of keeping track of it all, we just reset it at each level. And then we print a message. Congratulations, you're now level whatever. And we added that, because we added that on our prototype, anything that's been created with that constructor gets that same method and works as well, except it works using the information for that object as opposed to other objects. And this is the more common way for you to add methods to an object. Before, we were just adding them directly as properties on our objects, but it's much more common to add them to the prototype when you're building something like a prototype constructor. And one of the reasons for that is it's more efficient because they all share the exact same method. So if we change this method, like if we go character.prototype.greetings equals, and we're going to change the method like I did before when I had a typo, but we'll do it again. Console.log. We can see that all of the objects that inherit that same prototype have now had their method changed so that when they get called, they call that new version of the function. And so it's very efficient and powerful, and it's also a very powerful way to add properties to your objects in a sense, because you can add them on this prototype off your constructor. And by doing that, anything that inherits off of that will now gain that method. So now I strongly discourage doing this, but let me show you. You can do this all the way down even to the built-in objects. So we've looked at how object, if we did type of object or whatever, this is a function, but object is one of the built-in sort of objects in JavaScript. It's an object creator function, right? So we could do object.greetings equals function. Now everything that inherits from object is going to have a greetings method. So now our fighter, because I created it with a straight up object, simple thing, right? So what was our last one that we created? We created a dragon, right? Look, I'm proving wrong. This should work, but I've got some, oh, I know what I did wrong. Didn't add it to the prototype, right? I need to add it to the prototype of the object. There we go. Now let's see if this works. I don't know if this will. There we go. Now everything suddenly has it. But this is very dangerous because all objects will have that. And you don't want to do this in real life with these sort of built-in types in JavaScript, because other people will be creating, like your code will usually live in a place where other people's code is also running. And so if I created an object of foo, and I did foo dot somehow, it's like, that doesn't work. Doesn't work right because I didn't expect there to be a name, because I'm not some type of object, whatever. So you shouldn't generally add properties to these sort of built-in objects, but I'm just showing you that you could do it at any point. So, you know, if the character didn't have a greeting, if we deleted that, then when we did mage.greetings, it would look here and see that there's no greetings method. It would check the character and see that there's no greetings method. It would go down to the object type and go, oh yeah, there's a greetings method there. Go ahead and use that one. And it's just going to keep walking that chain all the way down until it hits null and it says, nope, nope, I didn't find anything, return undefined. Any questions about that?
So what would be the preferred method for doing I guess this one as a constructor or
There are factions. The best answer I can say for that is in JavaScript, there are factions. There are different groups of people who strongly prefer different approaches. There's a group of people who really hate these constructor because it's very close to classical object-oriented programming, and they feel like that's sort of a mistake. And the people who really like them have actually moved on to doing something called a class, which, I talked about the blueprint. It looks a lot like that. So you can create a class like, I think this works in Node. I'm not 100% sure. Let me try here. So you can create a class like this. It's like class foo. And I'm going to screw up the syntax because I don't do classes very often. In this class, you can write a constructor function as well. And this will, in this, you can set properties like you need to do this dot, but I'm not certain. Like I said, I don't write this syntax too often, so. And then you could do var, right? Var equals new foo, and var is. That's also a very common new syntax for people who really like the constructor functions. That syntax looks almost identical to traditional classic object-oriented languages like Java or C# or something else. It's a very common syntax. But it's just sugar. It's really just, we call it syntactic sugar. I wish there should be a really good funny picture for that, but I don't think there is. We call it syntactic sugar in software when you've sort of hidden a lot of complexity behind something so that you can write something much smaller and simpler and a whole bunch of other stuff happens. Like, I don't want to have to write this out. Like this console.log, I'm using these backticks and then just inserting my variables inside of this $$ so that it will interpret them. That's just syntactic sugar. I could write that out using, quote, quote, plus the variable name, plus, quotes, etc. But it's just a lot easier for me to write it out this other way. So this class syntax is just syntactic sugar. So there's a little bit of a war between them, and that comes down to how detrimental they think the is-a type relationship is. Because I mentioned that has-a is the preferred relationship, composition. And the terminology for that in the industry is composition over inheritance. You should favor composing an object of other objects as opposed to inheriting. And the general reason for that is because it gets fragile very easily. If you have a lot of different types that inherit from one object type, and then you need to change something on that base object type for some reason, or one of those types needs something very specific and different, or another property, it can get very confusing to know where the right place to put that property or method or other thing is. And so that's really sort of boils down to why they prefer composition. Generally, composition is preferred over inheritance when you're programming. Any other questions about this so far? All right. So I've got about one more item to sort of walk through, and it's sort of in the same vein, and then that'll be about it for any of this material, and then I might talk just a little bit about how websites and web servers work to try and start introducing you to that concept. But that's going to be much higher level. We're not going to go into deep code on that. So I also mentioned this object.create, that there's some more value you can get out of that before. And you'll notice when we were talking about it, I said, oh yeah, that's right. You always have to pass a prototype in to object.create when you're, you can't just call object.create with nothing. That's object prototype may only be an object or null, right? So this is another really powerful way. And again, this is the case of JavaScript being flexible to sort of reuse function or code. So I'm gonna be a little lazy here. I'm just gonna copy this in. But here I've got another, I'm gonna recreate this character object. In this case, we're just gonna create some farmer named John Doe. And we can check that it got created right by doing character.greetings and see the output, and we can look at his very easily. But let's say I want to create, again, a whole bunch of objects that are like this. And it's really easy because, hey, I've already created this. So maybe in this case, I should have made this like a horde of enemies in an RPG, right? That are all really the same thing. Like let's change this. We're gonna make our character like a Goomba or something. I don't know. We're gonna change games entirely. Or what's a good RPG type character? Enemy, yeah, we'll call him enemy. All right, we'll call it a slime. Sounds great. So name, slime, or we're not even going to give it a name for the most part. Most of these slimes aren't going to have a name. They're just some sort of nameless thing, right? Class, slime, XP, gained a tiny bit. Level 1, strength. This is slime. It's like really weak. Intelligence, and it's really dumb. It's some sort of slime, right? All right. So we've got this sort of enemy slime. Now we're going to encounter a bunch of these, right? Again, we've used these constructor methods. We've used other things. You can use this to set the prototype for a whole bunch of different objects. So now, if we want to create an object like that, we can do object.create and use enemy as our prototype. The interesting thing is this slime doesn't have anything unique to him. But if we did slime.proto, we can see all of those properties. And if we did slime.name, you'll see the empty string, or slime.class. And that's because, again, it's walking down that prototype chain to try and find the properties. And now, if we want to create another one, now we have, let's give this one a name, Qbert. So this one's going to be created off of it too, but now Qbert will get his own name. Because he's a unique one, and he's going to be a little stronger than normal. If we look at him, we can see he has a name and a strength, but he still has all the properties that he inherited from his prototype. So that's sort of another use of this object.create, is it very easily allows you to use an existing object as your prototype when you're creating new objects. Now, a lot of times you wouldn't use something with like real properties on it, like with values, but you might use something that you've set a whole bunch of methods on. Was there a question?
You go back up to the terminal. Parse.
All right. Any questions on anything we've covered today?
For the last part, where will be the good, I guess the best use for something like this for object create? I guess when you're trying to create multiple things quickly and easily.
I need to jot this stuff down so I actually remember it. Let me see if I can find it real fast. A good reference, an ancient one. Ago, in a galaxy far, far away. No, in this galaxy, there was JavaScript used to have a really bad reputation. A lot of people just didn't understand how it worked, and so this guy named Douglas Crockford did a lot of explaining about how to write code in JavaScript. And one of the things that he recommended very heavily back then, I don't know if I'm going to be able to find the reference or not, was to use this object.create syntax when you're creating objects. And I don't know if I'm going to be able to find it in his site immediately, but this might be a good, let me see. So you'll see he talks a lot about using this as one of the syntaxes for a way of creating objects. And I mean, I guess it's really just sort of, it's different syntaxes for different needs. There is a value to using this object.create syntax because you set a different object as your prototype. It also allows you to pass in an additional parameter of other properties to sort of set on your object while you're creating it. And it sort of steps you away from, I think it's a good idea in some respect because it helps decouple you from using the new operator, which if you're familiar with other languages will bind you to that form of thinking, to thinking about classes and stuff. And using object.create sort of frees you from that. But it's a little bit of just sort of preference as well in terms of which approach you want to use. The easiest to understand, given other languages and stuff, is the new operator and the new constructor. It works a little different than other languages, but it is somewhat similar. Any other questions? You had one?
Relationships between like patterns, so like how we create objects. There's different ways to do it, but I'm confused about what makes them different.
What makes them different?
Yeah. Because like we pointed it out earlier, like just like one had there was like a difference. I didn't really get.
Yeah, the difference was that when you use a constructor function, turn the lights on, it's starting to get dark. When you use a constructor function, the constructor function itself becomes the prototype for the new object created. So that's really probably the biggest difference between any of these approaches, is the constructor function will become the prototype for your objects. And that's, if there's any way that I'd probably recommend you getting familiar with and comfortable with, it's probably using constructor functions to create objects. That and object literal syntax, but object literal syntax is sort of easy, right? It's okay, I just put some brackets, set some things, and I've got an object. Creating repeatable objects of a specific type, the constructor functions is probably your best bet in terms of both what's the most common out there for documentation and what will give you the most flexibility for setting properties on prototypes and other things. Really, probably the biggest reason I introduced the different approaches is because, as I said before, he was asking like which approach is correct for how to do some of this stuff. And unlike other languages where it's like, this is the way that you create objects, this is how it works, JavaScript says people all over the field on how to work with it and how to create objects. So by introducing you to the different approaches, I'm just wanting you to be comfortable when you see them, when you're looking at other code. Like, oh, this isn't something exotic or different. I'm just creating an object. This is creating an object too. They all might have slightly different behavior, but it's all just ways to create objects. Now, I'm sure I have something here somewhere to document what I'm going to talk about now, but I think I'll just whiteboard it instead just a little bit. But I just want to, in the last like little bit of time, I guess, put some lights on so it's not so dark in here, maybe. But let's talk a little bit about just a website and how a website works in general, because we've talked a lot about JavaScript as a language. Normally, JavaScript lives in sort of one place on websites, and it's useful to understand where it lives versus where a lot of other languages live. Now, this isn't always the case, but this is sort of how it traditionally works. So whenever you make a request for like a website of some kind, put a big cloud here, and this is you, because I'm a horrible drawer, sitting at your computer, typing away. Can give you a little keyboard here. Yeah. Some sort of screen. And you're going to, I don't know, we'll go to Google, right? Because it's the traditional example. Can anyone tell me, like, this is complex. I think I sort of showed that site early on. Can anyone maybe try to explain what happens when you go to google.com or something like that?
So your computer to access the server, if the server is available, it'll send back saying, yeah, here's your website.
I mean, that's pretty good. So I'm going to gloss over some things, because the first thing is, like, if you ever try to break this down, you go, wait, how does it even know where google.com is? How does it know what this is, or how to get there? And there's a lot of complexity behind that. There's an entire huge infrastructure behind how that works. But let's assume your computer now knows, okay, I know how to go request something from Google. So the way a website works is, here's like Google's servers. So it's out to the internet. And the internet, being the all smart internet that it is, knows, oh, I know where to send that request. I need to send it to this computer over here. And that's all that a server is it's just a computer, right? So you can just call it their computer. And then Google's computer says, oh, where are you trying to get? Oh, you're trying to get google.com. And internally, it's got some code that knows what to search through arrays, for example, in our class already, and we try and return maybe a specific value out of the array, right? That's sort of what's happening here. It's just saying, oh, I know what to return. And there's software that runs back here to generate that page that you're getting. And then Google sends that back. And what it sends back are all of the resources for google.com. So that'll be the HTML, any images, any CSS, which is styling, any JavaScript. And we'll look at this on the computer in just a minute. But it sends back all of these different files. So a bunch of files actually come back to your computer. And then and CSS. and then it knows to execute the JavaScript. So once this all has come back to your computer, now the page starts rendering, but it's not, it may or may not be done. If it's just HTML and CSS and images, then it's pretty much just your browser doing some rendering. But we've been writing a whole bunch of JavaScript, and we've been doing it just in these small self-contained things. However, a lot of times what will happen is a website has some JavaScript on it to change that site a little bit. And that doesn't run back here on the server. Your computer will create the web page locally, and then that JavaScript will run against whatever happened to load on your page and make changes to it or manipulate it, change what you see, change what's going on. So in this way, like a server is able to send back a small little bit of, like these are all sort of just things that your browser knows how to handle, but this is executable code that can totally change the way that your web page works. And that runs on your computer. So the server here runs some code, and it might be, it might be C#. These are just other programming languages, or PHP, or Java, or it might even be JavaScript. And this code generates all these files, in a sense. It may not, it may already have some of them, but it's what produces all the content that's going to get sent back. So this is the server code that's running. And then all of this is going to run on your computer. And this is typically what's known as a client. Is whatever's run on like your computer. So if we did go to Google, let's again go back to this world's first web page because it's really easy. Right, we've used this as an example a few times. And the reason we use it is because when we do pull up our resource viewer here to see what's going on, we'll reload this page and we'll look at our network activity. Let's see that there was basically just this one little file that got sent down, right? Ignore this one because this is some extension I have or something, I don't know, built into Chrome. So just one file, very simple. But if we go somewhere like Google now, see something completely different going on over here. So now we see all sorts of files coming through. And we can even, the developer tools inside of Chrome are very useful. They let us filter by different files to look at what came through. So let's say, what images should we pull down? All right, let's sort of preview these. Hey, there we go. That's the logo. Another copy of the logo. Looks like a whole bunch of different icons of some kind, all grouped together. Here's a photo of me because I must be logged in. A bunch of more icons. All right, now let's look. What about CSS? Interesting. We didn't see any CSS files come down from Google. I'll bet you that's because I'll bet they've just embedded them directly into their HTML that they send down. XHR, this is something complex. We don't really need to worry about it. But we can look at JavaScript files. Now we get to see. Now they've done a bunch to make this code unreadable so that it's easier to send over the network, really, is why they do it, not necessarily to make it unreadable. But you can see all of the code that just came down when I hit the Google homepage that's running on my system right now, doing different things. What? Right. Yeah, I strongly recommend if you guys want to learn, code and just get better at it, find sites. Google is probably a very bad example because they're going to be highly optimized, but there are a lot of sites that you can pull up the network tools for and get a lot of information about what's going on with their site and start reading through the code and learning something. Like I say, they're going to be very heavily optimized. but I don't know if I can think of a site that's going to be have some bad code on it. It won't be optimized, but there's a lot of stuff like that out there, and you'd be able to look at it and learn a lot about what's going on. Also, usually, and I don't know why it doesn't show up here right now. I might need to play with my settings. Oh, because I'm not in my the right tab. If I go and look at my sources tab here, even in these files that I can't really read right now from Google, they have a button here that's like pretty prints that you can click, and it'll help format some of it for you and make it a little easier to read. Now, this is all really bad because they've minimized the code heavily. But that's all just JavaScript running on this page, changing things. And you can do that also. And this is, again, something we haven't gotten into very heavily because we've been focusing just on the fundamentals of the language as opposed to trying to teach you, how to play with a website. If people are interested in that, maybe I'll post some extra videos or send something out around that later. But you can manipulate the different elements on your page, for example, with JavaScript. So, all right, we've got this image of Google. And because I know a lot of this syntax, this %0 is sort of a shorthand way in the dev tools to say the element that's currently selected. I'm getting an HTML element, and look at that. An HTML element is just, this is an object with a whole bunch of different properties on it, including, for example, a constructor. The constructor for this is just HTML image elements. That doesn't sound too surprising. It also has like a border. And if we look, we see there's no border property on it. And a height of 92. Well, now I'm feeling a little silly. Maybe we can play with this, right? Maybe we make the height 200. What happens? It's just an object, just like any other object. I just changed one of the values on it, right? So now it's really stretched out. Let's go back to 92. It looks better that way. Let's find another property on here to play with. Name. It doesn't have a name. I don't know if that would do anything. Actually, I sort of do. I believe if we give it a name. I'd be wrong here. Let's see. Might be wrong. Or it might just be a little screwed up right now. We can play with some of these other properties, if you will. I'm getting at here is essentially just covering a little bit of this, right? That's JavaScript. So you notice that anything else I mentioned, like C#, PHP, Java, none of that is in my browser. And that's because any of that code was just used to generate these files, this content that did come down. And then this content that did come down, I need to reload the page because I shut the tools down. This is the only thing that actually comes to my computer and then can be run. Like, here's all their HTML, which has JavaScript embedded in it too. But that's going to be really important, especially as we move to the next class and start talking about building sites and generating content. You're really gonna want to have a solid understanding of how web servers work, at least at a basic level. So I'm introducing the concept now to start getting you thinking about it, because we found one of the most common pieces of confusion when people start working on their code is, where is my code running? And when we start building out websites, it's where's my code running? Well, when you're doing JavaScript, unless it's Node code sort of sitting on the back end, your code's running in the browser. Any questions on that? Anything? I'm gonna